Hi, I'm Michael Rainsford Ryan, and this is my final year project for computer game development at IT Carlow. Blockchain technology has seen a massive surge in relevance over the past few years, and with the boom in the cryptocurrency market over the pandemic, blockchain games have also seen a significant rise in popularity. These games come in many forms, but nearly all revolve around their blockchain aspects, with many of the rest of the features not getting the attention necessary to make a great game. Though this isn't without reason, as the demographic who tend to play these games usually do so with only the thought of making a profit. With this project, I aim to investigate the process of making a blockchain game and the technical challenges of such, while also trying to develop something that not only created the potential for players to earn money through play, but also a game that people would come back to purely out of enjoyment. In Mecha-Miners, the game I developed for this project, I wanted to try and capture the feeling of working a dangerous job to make a living. In the game, you play as a poor citizen of a dead-end planet who turns to a career in mining, which, in this age, has become a perilous industry, with many competing companies using violence to procure the valuable goods of dying planets. The game sees you drop onto the surface of unique, procedurally generated planets and battle it out with other players and intelligent robot miners, armed with useful gadgets and weapons to procure the crypto minerals beneath the surface. As I had recently started using the Godot game engine before starting the project, I wanted to continue with it and see what I could make. I had previously built a small prototype of Mecha-Miners for the Ludum Dare Game Jam, and wanted to expand upon it further. I had some experience with networked games, but never really attempted real-time networking, so for this project I wanted to try build upon my networking experience further, using what I was learning in college this year. Like many others, I grew interested in cryptocurrencies over the pandemic. From there, I grew an interest in the possibilities of blockchain video games. I was disappointed by other games in the market, as none seemed to have been made with love, but instead as a quick source of profit. For this project, I aim to research blockchain technologies and gain an understanding of their inner workings and the economics around them. I wanted to implement blockchain technologies in a game made with Godot. I wanted to implement real-time networked multiplayer with user authentication. I wanted to implement many unique and interesting features to go alongside the blockchain aspects. The first things I added to the game was a player that can move around, jump, and fly with a jetpack. I then made a tile-based, destructible world. I gave the player a gun and a drill, both of which can be used for mining and combat, with varying levels of efficiency in both. For the blockchain aspect, I researched many tools and libraries before stumbling upon Engine. Unlike many of the other APIs I found, Engine provided platform-specific interfaces as well as a general GraphQL API. Using this and a GraphQL add-on for Godot, I implemented an Engine API interface. The interface I built allows you to authenticate users, create transactions, manage your tokens, and validate requests, all of which are featured in the game. I also created a dedicated cryptocurrency token called Elixirite as the game's main currency and the minerals you mine from the levels. The game uses Godot's built-in multiplayer capabilities to provide online and LAN multiplayer. The server was hosted on DigitalOcean, but due to costs, it's no longer running. To access the multiplayer capabilities, players must first log in with an Engine account, link their Ethereum wallet if they have yet to, and then they may begin the game. Alternatively, players have the option to play offline, but they will not earn cryptocurrency tokens from this, as there is no server to validate their game. Making the game primarily multiplayer meant that without players, the game wasn't much fun. To fix this, I implemented robot miners in the game controlled by AI. The AI is capable of doing anything the player can and is designed to act like a real player. There are two types of AI, a smaller miner drone and a larger battle miner bot. The AI use a behavior tree implemented as a prioritized finite state machine and use decision trees for behavior transitions and decisions. Each AI has several sensors that detect the state of the world and informs the behavior transitions. The AI have a number of stats, such as bravado and greed, that determine the severity of risks that they're willing to take. Each of the AI behaviors also includes some level of controlled randomness, which, when paired with the previous points, help create emergent behavior. The AI will also remember certain information, like the path they took and which miners have attacked them in the past. This information is used to inform future decisions, like showing more aggression towards miners that have attacked them in the past. Additionally, the behaviors and sensors use numerous algorithms such as Dijkstra's, A*, and sorting algorithms. To keep the game interesting, each level is procedurally generated using open simplex noise, which is essentially an open source version of Perlin noise. The generation is completely parameterized, meaning nearly all aspects of the world can be modified in the editor with instant feedback without touching a line of code. The ground level is generated first, then 2 or 3 main caves are generated from the lowest point of the ground to the bottom of the map with varying widths throughout. Additional caves are then branched off, minerals are spread throughout the caves, and grass is laid upon the surface. Finally, all tiles are updated to show the correct texture in relation to each other. Most crypto games I've found are built for the web and natively communicate with blockchains through well-refined interfaces and APIs. Making a blockchain game in Godot required me to write a brand new interface for a blockchain service API, which introduced many new challenges. A lot of Engine's documentation is out of date, which didn't help the process, but there were no real alternatives. Thankfully, their support was incredibly helpful, although we're from a different time zone, so communication was quite slow. As my project was focused on making a game that did not solely revolve around blockchain, I believe I went too far, and as such, the cryptocurrency feels somewhat out of place. On the upside, using Engine allowed for secure, low-cost data storage, transactions, and authentication. Through the struggle of creating the interface, I learned a huge amount about GraphQL, Engine, and blockchain tech in general. And by focusing on other aspects of the game, I furthered my knowledge in various areas, such as networking, procedural generation, AI, and game balancing. In hindsight, I would have liked to implement the blockchain aspects earlier in development, and I feel I could have better expanded on them. Multiplayer is a lot more difficult to get right than it looks, as even the smallest interactions provide layers of complexity. Playtesting has been absolutely invaluable and should be used often, even during the early days of development. I got amazing insight from the few informal playtesting sessions I ran. I only wish I had held more. The project was tough and I definitely lost some sleep over it, but I'm really happy with the outcome, though it wouldn't be anywhere near it was with all the amazing people who helped me throughout the process. And on that note, I would like to thank Michael Gallegos of Engine, who gracefully helped me work through the many issues I encountered during my time learning and using the Engine API, and apologies if I mispronounce your name. I would also like to thank Lei Shi, my project supervisor, who showed enthusiasm and support for my project even when I couldn't bring myself to do the same, and pushed me in the right direction when I was lost. And finally, I would like to thank all of my lecturers and classmates at IT Carlow for giving me the skills to create this and the motivation to continue. Thank you for watching.